three basic issues which we want to discuss about the sound today is the first I will try to calculate the size of a file for mono recording and the stereo recording. So, we will try to see now you will see that for mono recording you require less memory size than the stereo recording, because there you have to do the recording for double tracks now. Then we will try to talk about the digital communication standards between for the electronic musical instruments and the computers. So, we will more time we spend on the MIDI which has emerged as a standard for the musical instruments. Now we will talk about the MIDI hardware, we will talk about its cable, we will talk about various ports, we will talk about the basic components of a MIDI, and then finally we will talk about the MIDI file, what does it comprise of, and then try to compare between the MIDI file and digital audio files. But before going further, let us review, we have a quick review of what we have discussed in the previous sessions, because it will help you to understand what we are talking today. So, the basic thing, basically three issues of what we have discussed last time is, first we discussed what is sound, we explained you the physics of sound, how does our brain receive something as a sound. Then we talk about audio basic concept, we discussed audio basic concepts, we talked about waveform, we explained you what is a periodic waveform. When we say periodic waveform, what we exactly mean by it, that it is a wave which repeats at a periodic, or which wave which repeats at a fixed interval time. For example, we took example of a sine wave. So, sine wave is also one example of a what we call them waveform, and we gave you very simple example of a waveform, but we can have a very complex waveform also, but all the complex waveform also can be broken into the simpler sine wave. So, you have to understand how the information is stored basically inside the computer, that is in waveform. And also we discussed various other qualities of the sound, various other attributes of a sound. For example, we discussed the pitch, what is amplitude, what is the frequency, what is the noise, and what are other qualities of a sound. And we also try to compare between analog and the digital signals and analog and digital audio. So, our focus is much more on the conceptual part of the multimedia, and you must understand the difference between analog and the digital signal, then only you can understand the difference between analog audio and the digital audio. Let me just quick have a review of what we discussed about the analog and digital audio is that you basically there are certain advantages of a digital signal. That is why there are certain advantages of a digital audio, and what are those advantages? For example, all the compressions techniques which we will be talking at a later stage are basically designed around the digital audio, not around the analog audio. The number one. Number two is that all the security mechanism are again designed around the digital signal, not around the analog signal. But you have a certain advantage of analog signal. For example, you require a less bandwidth of a analog for sending the signal in analog form, because certain informations like for example voice or the speech or video, they are basically by characteristic they are in analog in nature. So, you do not need to translate them into any other form. So, you require a less cost, less bandwidth for sending analog signal compared to digital signal, but certain advantages of a digital signal you have that you simply are basically you can't compare with the analog signal at all. So, same advantage you have with the digital audio now. And finally, I was talking about that is basic thing you must understand, right. It is not very new topic we have taken up in the CSI 13. CSI 09, again we talked about these two basic things which you have to understand. What we are talking about the digitization techniques. Now, for example, the analog signal can be converted into the digital signal, right, and what are the basic techniques for conversions of analog signal into digital signal. And last time I was showing certain diagram. So, basically the three steps are required for conversion of analog signal into digital signal. Let us look at this slide now. See, basically two steps I have written, third step I will just tell you. The first is what we will call them sampling. Sampling means taking the amplitude value of your signal, taking certain value of your signal at your x axis or y axis now. So, we are talking about amplitude of the value now, and and more details we will be talking at a later stage now. And the second one is what we call them quantizations now. Quantization means that putting all these value you have to do some integration, or basically you put them into the integer value. For example, what we are talking about is, suppose that if you have taken 8 bit as a resolution of your audio card, then your maximum range is between 1 to 256 or 0 to 255. So, all the value have to be between 256 only. So, if you have got certain sampling value more than 256, it has to be truncated among 256 only, not more than that. So, again let me repeat once again, the first process of conversion of an analog signal or analog audio into a digital signal or digital audio is, first you have to do sampling. You take the amplitude value of your sine wave, that is the value of on your x axis, and then you try to quantize them depending upon the range you have taken. If your range is based on 8-bit audio card, then the maximum range you can have between 1 to 256 or 0 to 255. So, if any amplitude value is going beyond 256, you have to clip them or you have to truncate them and bring them at between only 1 to 256. So, this is the second step in conversion of your analog signal into the digital signal. And remember, in the first trimester, again I repeated in the second as well as in third trimester, we ask what in basic concept, what is the PCM, what is the pulse code modulation. So, when we say PCM is a basically digitization techniques, conversion of a analog into digital signal, which comprises of 3 steps. Once again, it is sampling, the second is quantizations, and third is what we will call them encoding. Now, how you are trying to convert them into 8-bit or a 16-bit or higher than that, and most of the audio series which you have or most of the audio card which you have inside your machine is based on 16-bit resolution, which will again will be talking about. So, 3 steps you must remember: sampling, quantizations and encoding, which is required to do conversion from audio into digital signal or digital audio. Now, again let me see what we are talking about is then you can ask the questions now. Then what is, how the sampling rate or sampling size are going. Let me define 2 basic related terms with 2 terms related to sampling. One is called sampling rate and second is called sampling size. Try to understand what is the sampling rate. I am again repeating what we have discussed earlier so that you understand what we will be talking today. How often the samplings are taken is the sampling rate. How frequently you can take the sampling is called sampling rate, and the amount of information stored about each sample, that is the sample size. Now, that 2 things are very related now, and that will later on you will see these 2 will have a major impact on the size of the file. What we are talking about is that if you want to produce good audio sound, good audio quality or good audio CD, then the sampling has to be done very fast and the size of the sampling also has to be very large. What exactly we are talking about is, for example, if I have taken 8-bit resolution, what exactly it means? It means that the maximum range of your amplitude value will vary from 1 to 56 or 0 to 256, 0 to 255. If you take 16-bit, again I will repeat later stage, you have a amplitude value will be much larger. So, what we are talking about is that if the sampling rate is higher or sampling size is higher, then the audio quality also will be much more higher, but again at the cost of what? You just think over it. I will give you answer to this question at a later stage now. So, right now 2 terms are very much related. One is called sampling rate and second is called sampling size. Now, how frequently you are doing this sampling, that is called sampling rate. See, according to one theorem, that is called Nyquist theorem. According to I am talking about how to decide what should be the sampling rate. One is that if I have to take higher sampling rate, then only I can produce good audio, that is understood, but how there is some relationship you have to understand about taking of sampling rate. According to one rule, one theorem, you remember we have discussed 2 theorem to calculate the channel capacity. You remember from the previous CSI 9 perhaps, or CSI 9, yes, there we introduced 2 theorems. One was Nyquist theorem and second was called Shannon's theorem. Both are used to calculate the channel capacity given the bandwidth of a channel. For example, I have a cable, I have at home I have cable connections. So, the cable which carries this signal, the bandwidth of that cable is around come to around 500 megahertz, that is the bandwidth. So, if I have to calculate the channel capacity, number of bits per second which can be carried by this cable is again dependent upon the formula introduced by Nyquist. Again the sampling rate is also dependent, again the sampling rate is also can be calculated by the Nyquist theorem. Nyquist theorem says that if I want to capture all the intelligence of a sound, then the sampling should be twice the bandwidth of your channel. For example, we take example of a telephone line which carries your speech now or voice now. The bandwidth of this telephone line, it comes around 4k hertz. It means that how, if I have to convert this speech into the digital signal, then what should be the sampling rate? It will be twice the bandwidth. So, for example, if you have a 4k hertz, that is the bandwidth, then sampling will be 4k hertz multiplied by 2 comes around 8000 samples per second. Means 1 divided by 8000 means so many microseconds, or let us say come to 125 microseconds. Means every 125 microseconds you have to do one sampling of a signal, otherwise you will be not able to reproduce the audio as it was. So, this is what you have to understand, the theory behind all the thing, right. You sometimes must think that when you have a audio CD, you must understand now from your multimedia courses that what is the frequency range, what is the sampling rate, what is the sampling size, right. As any multimedia professional know how to play with the all these packages, Photoshop and all the thing, but you as a professional must understand that what is basic theory around producing a digital signal or reproducing a signal as the original one. That is something we are talking about at this stage, right. Now, for example, this again already have repeated now. This is what I am talking about, there is certain relationship among between sampling rate and sampling size and the audio quality. And what is that? Just read once again. More often you take a sample and more data you store about that sample, the finer the resolution and quality of the captured sound when it is playback. That is something you have to understand. Most of the audio CD, which I will repeat again in different slides, that most of the audio CD which you carry at home or buy from any market to see all the music and songs and so on, they have a minimum 16-bit resolutions now, right. And the frequency range I will talk about little bit later on. So, you must understand these two basic characteristics about the audio CD which you come across. Now, the answer the question which I raised here, like what are the sampling frequencies of your audio CD, right. So, here is the answer to this question, that the 3 sampling frequency used in multimedia are CD audio quality. So, these are the 44.1 kHz, 22.0 kHz and the 11.0.2 kHz. This is basically the sampling rate, this is called, right. And the size of a sample, what exactly we understand, many times I have repeated this word sample size. What exactly you understand by sampling size means how many bits you require to store one sample, right. And if you have used more bits, then the quality of the sound will be very high. So, most of the audio CD comes around 8 bits or 16 bits. So, each sample of the audio CD takes around 8 bit or 16 bit. Now, everything is standardized around 16 bit of the resolutions. Now, let us talk about now the impact on the larger size. Let us see here, the larger the sample size, the better the data describes the record sound. So, if you want to have a audio quality, good audio quality, you go for this higher side sample size. An 8-bit sample size provides only 256 equal units to describe the dynamic range or amplitude. You must understand what is amplitude, what is the dynamic range. So, basically we are talking about for producing the good audio quality, you go for higher size sample size and go for the for higher rate of the sampling. So, now one thing always remember, which I have repeated many times, that you must understand that when we say the sampling, it always relates to the digitization techniques which have a what we will call them encoding which we have a quantizations and called the sampling. So, right now we are talking about only the sampling part of it. Now, so basically you must understand that if I have a sampling, if I take 16 bit, then I have very higher range for capturing the sound, right. So, basically we have 2 to power 16, it comes to around 65,536. So, if you have a 8 bit, you have only 256 different value of your amplitude, right, but if you have a 16 bit, then your range is much more higher. So, it means that that more better quality of the sound will be produced by if you take the higher sample size. Now, basically the problem is it is somehow related with quantizations. Now, we have finished the what is the sampling, how, right, what is the sampling size, what is the sampling rate. For better audio quality, you have a both the factor must be at higher side. Now, let us come back to the quantizations part. What is important related to quantizations? Let me repeat once again. When we say quantizations, means I am taking the round of value, I am taking the integer value of my amplitude value. If I have a, for example, if I have taken amplitude value on the x axis 256 point something, right, but my range is only 1 to 256, means I have to truncate my signal, it has to be only between 256, and that is the quantizations. So, what exactly? Let me explain this term. The value of each sample is recorded to nearest integer called quantizations, and if the amplitude is greater than the internals available, that is 256 or 655,000, clipping of the tops and bottoms of the wave occurs. That is what we are talking about, the quantizations now. So, if you have taken less amplitude value, if you have taken less bit, you have to do more clipping, but if you have taken the bigger range, then you have to do less clipping, that you understand, because you are doing the sampling at very less interval time compared to the if you have taken low sampling size. Right now, so basically, and two techniques now here, that is point is to, we have PCM we have referring to. So, two well known example sounds are telephone, which is used where, and audio CD, right. So, in audio CD also we use sampling, in the telephone also we use the sampling, right. So, and in telephone, this is called PCM, we use 7 bit. In Japan, this basically PCM, when they do the digitization using PCM, they use 7 bit or 8 bit in Europe, and this the data rate comes around, that is something you can simply calculate through your Nyquist law, that if you take this sampling, if this is the sampling, then what will be your channel capacity, that can easily be calculated by this Nyquist theorem. Must remember, Nyquist theorem gives you the sampling rate, it can also help you to calculate the channel capacity. So, if I have a 500 megahertz channel bandwidth, then if I have to calculate the channel capacity, that how many bits per second, using Nyquist law will be simply twice the bandwidth, means 2 multiplied by 500 megahertz, it comes to around 1000 Mbps. That is some same formula we have used, but not in using the Shannon's law, because in Shannon's law the formula is entirely different. There you have to calculate the noise and the noise ratio, noise to signal ratio, that is logarithmic value of this one you have to consider. So, these are the basic fundamentals of the communications theory, not something multimedia itself is not a very standalone course. Some principles of physics comes here, electronics, the computer network comes into it. So, all the issue you have to understand the basic principles of the multimedia. This is what we are going to talk. Now, and again the frequency range of a audio series, that is something you have to understand. In fact, we have given you 3 figures for these are 3 figures used by different manufacturer. One is 44.1, then we have a 22.0.5 and something like this, and there is another 3. So, 3 frequency range or 3 sampling rate are used for producing audio series, and the sampling size is either 8 bit or 16 bit. And let me repeat again, most of the manufacturers today have a standardized around 16 bit of the sample size. Now, the point is the quality now. and we have referred to many times. I tried to explain to you, but let me summarize very quickly that let me see this slide once again. Although we have explained this concept here, that the sampling rate determines the frequency makeup of the recording. Sampling at higher rates more accurately captures the higher frequency content of your sign. This is basically I am trying to compare the quality and the what we will call them file size. The second one is again the resolutions, like 8-bit or 16-bit, that we call the resolutions now. The resolution also determines the quality. The resolution determines the accuracy with which a sound can be digital. Using more bit yields a recording that sounds more like its original. So, again same, both are going into same directions, that more sampling bits, more sampling rates and more sampling size both lead to high quality, but at the cost of something which I raised the question earlier, and you must think of because everything is not a free of cost, you have to pay some price for something, right. If you want to have a higher quality, then the size of a file will be very high. For example, if I want to store the digital, if I want to store colored image, then my file size will be much more higher than if I want to store black and white, because you have to store the information related to colors also. So, again file size, you have to add the cost of the file size, at the cost of the CPU time. If you have the file is very high, then the processing time by the CPU also will be very high. So, all the issues, trade-off are there. You have to understand as a multimedia producer, you have to understand all these basics. The higher the sound quality, the larger your file will be, that you have understood, and this is what I was trying to explain you so far, that relationship and quality versus file size. Now, this is what we have already discussed. I repeated once again that you must understand the flow of what we are going to talk about. Now, let us start with the three major topics which we are going to discuss. We have just 35 minutes time now, and little bit I will be a bit faster because the basics must be understood now. Again, little bit of mathematics we are going to talk today, that you have to calculate if I have to do the mono recording, if I have to do the what we will call the stereo recording, then what will be the size of my file, right. Basically, the course is very theoretical. You have to understand this course not only from the package handling point of view, but also the basic principles also you have to understand. Now, what I am going to talk about is how to calculate the size of a file if I have to do the mono recording, right, and the studio recording, and various informations are required, and that you will see later at a later stage, that if my recording is of larger duration, then again the size of file will be more. If the duration of a recording will be lesser time, then it will, the size of file will be also small. So, size of a file either be for mono recording or for stereo recording is of means 1 minute will be larger than the, let us say, 10-second mono recording or stereo recording. But the point is for a stereo recording for the same durations will be much larger, twice larger than the mono recording, because you are using a different tracks for it, right. So, this is what we are talking about. Let us talk about what is the mono recording, although you know now what is the mono recording now. Now, let us see, the stereo recordings are much more lifelike and realistic. Most of the people are going about the, like for example, FM radio are basically stereo recording. Everybody listens to FM only because this is stereo recording, and most of the traditional work is basically mono recording now, and most of the audio CD today comes as a stereo recording now, realistic one now. So, the stereo recordings are much more like a stereo recording are more lifelike and realistic because human beings have 2 ears. Mono recordings are fine, but tend to sound a bit flat and uninteresting when compared with a stereo recording. That is something you know from the from your basics. Let me talk about is that in terms of a storage requirement, stereo recording sound files, because they do recording for both the ears, they use more than one track. So, stereo sound files require twice as much storage space as the mono files. Now this is all, but let's try to see the formula. You must understand this formula. Although we are not going into details of derivations of this formula, you have to simply understand the this application, just like in Nyquist law and Sinus law. We simply, but you have to understand the its various component rather than how the formula has been derived. Now one can easily make it out because it is not a very difficult to derive as well. Now what is that? Now what is this formula? Now there is a small mistake which I will try to correct here. For a monophonic recording or mono recording, the formula is what we are trying to calculate. We are trying to calculate the size of a file, right. So now for mono recording, the size of file will be you have to know the sampling rate, it thousands or 8 kHz or 44 kHz or 22 kHz depending upon what frequency range you have taken, the sampling rate multiplied by duration of the recording, 10 seconds, 20 seconds, 60 seconds in second, multiplied by bit resolution is 8 bit or a 16 bit, multiplied divided by 8 to calculate number of bytes, multiplied by 1. This is not plus 1, just to make it correct, this is basically multiplied by 1 because it is for mono recording, for 1 year we are doing. So now you must know the what are the parameters we have taken for calculation of all these. We have taken the sampling size, that is why we explain you what is the sampling size, 8 bit or 16 bit. Then we have to take the sampling rate. I gave you example how to calculate sampling rate, that also I explained you using Nyquist law, twice the bandwidth. And then you have to aware of that what is the number, how many seconds you want to use to do recording, whether in 1 minute and so on. So multiply so many bytes you required for the mono recording, and look at the what is the main basic requirement for the stereo recording. The same way, simply you have to multiply it by 2, right. So again for a stereo recording, the size of the file will be again same as sampling rate multiplied by duration of the recording in seconds, and again bit resolutions divided by 8 multiplied by 2. So this is what the two basic formulas you have to be aware of. Let us see few example how to calculate now, right. So you can easily calculate now so any multimedia professional must be aware of that. If I have to do 1 hour recording, then what is the size? For example, if they are doing my recording, they know that this 1 hour duration, what will be the size of the tape they require and so on. So they know it. Same way you can easily calculate also. So here this is a formula. Thus the formula for 10-second recording, this is what we are trying to for the mono recording now, right. For this range, for this sampling rate, 8 bit resolutions would be, again you multiply the sampling rate, that is this is the sampling rate. I have simply converted them into the kilo route. So 22,050 hertz multiplied by 10 second, that is the duration of the your recording, multiplied by the 8, because 8 bit resolutions we have taken. If I had taken a 16 bit, it would have been 16 bit here, multiplied by 8 because number of bytes I want to put them as an unit, and then multiplied by 1 because you are doing what? You are doing the mono recording, right. Same way I can calculate for the stereo recording. Look at the stereo recording. Now what I have done this time, that I have changed my sampling size, sampling rate I have changed my resolutions, right. You can just simply calculate that for a stereo recording, if you have increased the sampling rate for producing good audio quality, then I have to increase the sampling rate, I have to increase the sample size, and you have seen the growth of your file size become very large, right, and so on. So this is basically give you some feel of certain theory behind that file size versus audio versus mono recording versus digital recording, and so on. So you must able to relate all these things together, then only you can understand the theory behind and how much memory requirement you have, you require it. As a simple professional, they do not understand this basic thing, but you as a software professional must understand these basic things, right. Finally, you have to have you have to go for a higher size machine. You must be aware of machine configuration in terms of the memory, in terms of the CPU and so on, audio card, video card. That is something you have to understand, right. The hardware part you have to understand as much as the software part of it, because the theories you are trying to, we are focusing much more on the theory of the hardware as well as the software. Now the right. This is basically the for your information, which I have repeated now several times. I am repeating it only for you, that you must understand the certain things information about certain things which you see all around now. Again I repeat once again that the frequency range, the sampling rate for the audio CD which is manufactured, which you have seen consumer audio CD are 44.1 kHz and 16 bd, because certain things which are very important I try to repeat so that you must remember, right. 16 bit audio, because there are things basic people keep on asking all the time. Okay, you have audio CD, you tell me you have done a computer science, you tell me what is the sampling rate, what is the sample size and so on, and how much information do you require to store if I have to do the digital recording or the mono recording. Now this is what my first topic for today, which I introduce you, right, how to calculate the file size for mono recording and the studio recording. Let me talk about the major topics that is called the MIDI. This something this is a very important topic. This is a standard, right. This is a standard, just like for example in network you have understood, we talked about many standards. Starting from my physical layer up to the application layer, we discuss number of standards. Like for physical layer, it somehow sits into the physical layer domain. In physical layer we talk about RS-232C. For example, if your mouse is connected to your computer, it is again there is standard, there is interface between this mouse and your this one. Your keyboard is connected to computer, again is based on certain interface, certain standards, right. So both mouse and this one is again connected to the serial port, but your printer is connected to the parallel port. So what is the serial port, what is the parallel port? They are basically interface, they are basically a standard for transmission of a data between the keyboard, between mouse and the computer, between keyboard and computer, and between computers and your this one. It's a very similar type of standards we are talking, which is used between the musical instruments, electronic musical instruments and the computer now. And because of this interface standardizations of these things, the audio quality has improved a lot, because today we are talking about the digital audio, and you have seen the advantage of the digital audio. You require less, you can compress them, you can do lots. Once you store your information in terms of bits and bytes, you can do all sort of signal processing, you can reverse them, you can clip them, you can combine them, you can add something more to it, which is not possible when you work with analog signal. So you have basic understanding must be clear about analog signal and digital signal, and you will understand all the things. Let me come back to this slide which we have started now. Communication standard developed in early 1980s for electronic musical instruments and computers. It allows music and sound synthesizer. Synthesizer is a basically device to produce a different type of sounds from different manufacturers to communicate with each other by sending message along cables connected to the devices. What we are talking about is that is a standard used for different musical instrument manufacturers to send the message from one to another, right, and information can be sent only through the cables now. So MIDI is a basically hardware device. It is the interface between the musical instruments and the computers, or between one musical instrument to another musical instrument, so that they can understand the pitch, the amplitude, the tone of the one signal to another signal, right. So MIDI provides the interface. Let me have more discussions on it. MIDI provides an interface between a musical instrument that is called synthesizer and a computer through a small piece of equipment that is connected to the serial port of the computer. So MIDI, if you want to connect any musical instrument through computer, then I must connect through MIDI. So MIDI again somehow supports a type of interface or a type of serial port, and allowing the transmission of musical signals. We will talk much more, we will take this topic in much more detail. We will talk about what are its hardware components, right, what are its software components, and what type of message is produced by it, how the system understands this message, and so on. Now so MIDI, again we talked about it is a communication standard, we talk about it is an interface. MIDI is basically protocol. MIDI provides you a protocol for passing detailed descriptions of a musical score, such as notes, sequence of notes, and what instruments will play these notes. So, this is basically just like a protocol we discussed, like RS-232. So, is a hardware as well as we can say it support the protocol. But take example TCP/IP. There must not be any confusion when we say protocol, it could be actual product, right. For example, if I say that TCP/IP is a protocol, now what is the TCP/IP? This is comes into a software. The TCP/IP is a protocol for, or is a standard for a transport layer and the network layer protocol. It comes into a software. If for example, if you purchase Unix operating system, so the TCP/IP comes as a one of the library. You take have a window NT, again the TCP/IP comes as one sort of library, but it can be designed into the hardware itself. If you work with the data link layer for your SDLC, they comes into the hardware component of it. So, depends upon how the manufacturer has supported that one, it comes into the hardware, it comes into the software and so on, right. This is a protocol for passing detailed, let me slide now, for musical score such as notes, sequence of notes and what instruments will play. You have to understand the each byte of the message going between two musical instruments or musical instruments and the computers. Now, more detailed I will be not be discussing it, up to your interest, but you have to understand all these things very well. Just like you understand the, just like for example, if I send a informations, if I have to send email, what I do now, how the computer transfers this email, they always transfer the information in terms of a packet, and this packet not only contains your email message, but also contains your address, the sender's address, the receiver's address and the actual data. Same way the informations among musical instrument through MIDI interface goes as a message which contains many things, and only musical instruments can understand. You as a human being does not have any for you MIDI doesn't produce any sound. It is basically sound only between the musical instruments. You as a human being cannot understand any MIDI signal. It is just like a controlled information only between computers and musical instruments. So, the MIDI signal may be recorded as only controlled informations, just like a controlled information. Most electronic instruments not only respond to MIDI data that they receive, they also automatically generate MIDI messages while the musicians play the instruments now, right. So, today lots of musics are being produced only synthesized only through computers, and only it is helping only because of the MIDI, because there is standard now among all the musical instruments now. The MIDI is a now, whether it is audio, whether it is analog or it is digital. So, MIDI is a digital communications protocol that manufacturers of electronic musical instruments have agreed upon. It is basically digital signal we are talking about, because computer understands digital signal. So, the message between the two are again into the digital form, and that is, this is the what we are doing with this is the basic purpose of the MIDI now. It is a set of specifications they use in building their instruments, so that the instruments of different manufacturers can communicate musical informations between one another without a difficulty, because there is a certain standard. Like for example, you try to understand what we are, I think there might be some problem for you to understand what we are talking about it. Like for example, when we say RS-232C, it is a standard for serial interface. So, any manufacturer who designs RS-232C, right, they know that which pin, there is an understanding that pin number 1 will be used for this one, pin number 2 will be used for this one, pin number 3 will be using for control, pin 4 will be using for this one. This is what we are talking about it. Had there been no standards, then anybody could have designed their own way, and then compatibility was not there. Today we are talking about compatibility, right. That is what we have to understand the old issues now. MIDI interface has a hardware that involves a MIDI port. What it comprises of? It comprises of a MIDI port and a MIDI cables for establishing a physical connections in the same manner as two computers communicate via modem. Now, if two computers are trying to communicate, we have to use certain modem. The speed might be different factor, like for example, I can 56 kbps modem or 96 kbps modem or 32 kbps modem, but two computers can communicate among themselves only through modem if the data has to be transmitted through telephone lines. Here same thing, the two system two musical instrument or one musical instrument and computer can communicate among themselves only through the MIDI port or MIDI device, and they have to be connected through MIDI cables now. So, MIDI, just like for example all the computers in this one in local area network are connected through certain cable, and this cable has certain specification 10 base 2, 10 base 5, what exactly it means. There is certain specification of this cable. The 10 base 2 means the 10 Mbps speed it must support, and the difference between the size of the cable is also fixed according to a specification. So, the cable has got certain specifications. So, you have to use MIDI cables and you have to use MIDI port if two musical instruments are talking among themselves, or computer, or you want to connect any musical instrument through your computer. So, there certain standards are there, right. So, the then what is the basic format of the informations going on between two musical instruments? The MIDI data format, that is digital, encodes the informations traveling through the hardware. Now, what these information contain? The encoding basically includes instrument specifications, when to start and stop playing a specific note, basic frequency and volume, and modulations of notes and so on. It is not only musical instrument can understand, right, it is not for us to understand, but musical instruments understand that what for this one, what for another one, and so on. So, you have to understand little bit of the specific the format, just like for example, if you work with Ethernet has its own format. If you work with token ring has own format, right, and if you work with token bus, it has own format, and so on. Same way, there is certain format which each manufacturer has to support now, then only compatibility between different musical instruments will be supported, otherwise it will not be supported, right. For example, what we are talking about, like this keyboard, this is a basically ASCII standard now, right. If some other manufacturer using a different type of keyboard, then again the whatever data I have input through this keyboard, if I want to play somewhere else, use somewhere else, it will not be understood, because the encoding technique using the ASCII is different from let us say example EBCDIC and so on. So, all things have to be understood. The so basically what we are talking about is that each MIDI command. So, basically each MIDI message communicates one musical event. So, basically message is called, one message means one musical event takes place between machine. Each MIDI command or message has a specific byte sequence, just like for example, if I have to see the TCP IP packet or Ethernet packet, there is a byte sequence, right. Same way it is a byte sequence, certain bytes has certain meanings and so on. Now, each byte, now first byte is called a status byte, which tells the MIDI device what functions to perform. You do not have to go into detail, but at least some meanings you have to understand. Encoded in a status byte is the MIDI channel, which channel they have to use now. Like in TCP IP we use number of logical channel, here also we use different type of channel. So, encoded in the status byte is the MIDI channel that is capable of communicating with other MIDI devices. MIDI standards specify 16 channel, right. So, use different type of channel, and one status byte is basically meant for which channel is being used for certain specific purpose. The now here are few specifications, like for example, MIDI interface contains 3 5-pin ports, like for example give you, that is a serial interface or serial port or the parallel port, right. 5-pin ports, these ports are labeled as in, out and through. Through these ports, computer can control the output of individual instruments now. So, if I connect, so I have to, if computer wants to take data from your keyboard, it always has to be connected through serial port. If it has to take data from the mouse, again there is a serial port for the mouse, right. If you connect this one through somewhere else, the data will not be accepted by this one. If for example, if you type something through keyboard, how does computer come to know that something has happened outside? Only through this port it receives the message, and then it comes to know that yes, through this port only keyboard is connected. So, there are 3 ports, right. So, input, output and through, and according to requirement you connect, information is travel through particular port, right. Like for example, what in does, in port accepts data coming from an individual instrument's sources, so that it may be reproduced by a sound generator, right. So, data computer receive through only input. What about the output? The output sends MIDI data out to the rest of the MIDI setup. These data result from the activity of the synthesizer, such as key presses, patch changes, and so on. Little bit you have to, if you see the book which we have prescribed you, lots of buzzwords are related, just like in network you have lots of buzzwords. Same way there are lots of many buzzwords like the pitch and or patch or synthesizer, the other things you have to try to understand. The MIDI information is basically again the cable. So, how again I explain you what is the port now and what are these ports for, right? Input what it does, output what it does, and then talk about the cable now. The size of cable is again 55, the higher side, but some of the manufacturers produces the 10 feet or 20 feet and so on, but more than 50 feet is not allowed. Just like the Ethernet cable is again 200 meter or 500 meter. If you have to have a more than 500, then must be some repeater in between and so on. So, again there is certain standards are there one has to follow. So, you must understand the cable length is 50 feet, right, and the data is passed through cables only. I can pass the data 1 bit a time. So, basically now the is a serial interface now. So, the computers, look at this slide now, the data goes through this cable between the musical instruments, and this one is basically what we call them serial port. It goes 1 bit at a time, right, and most of the manufacturers support serial port, because if you have a parallel port it will take more it will be much more costlier. So, MIDI manufacturers choose the serial interface because it is less expensive and more efficient than the parallel interface. So, again cost factor is also very much important, although parallel interface means many data can go faster at a time. Like for example, there is parallel interface between the computers and this one, because 7 or 8 bits can travel at the same time, whereas the data going from your mouse to your keyboard always go 1 bit at a time, but again is much more cheaper, something like this. The heart of the, now what again, the the heart of any system, MIDI system, is basically synthesizer, right. So, any MIDI system is MIDI synthesizer device. This is a hardware device, like it basically looks like a piano keyboard, and most of the synthesizer, basically purpose of this synthesizer is to generate this sound. So, they contain sound generators, they contain microprocessor to process the sound, they contain the keyboards, they contain the control panels, they contain auxiliary controllers and the memory. So, it itself is just like a mini computer, because you have to process many things. So, it has a memory, it has a microprocessor, it has a controller, it has a keyboard, it has a sound generator and so on, right. So, the purpose of the, and let me talk about very quickly about each component. Now, the sound generators do the actual work of synthesizing the sound and authoring and basically of the sound or controlling the sound generator. So, this is what the purpose of the sound generator, produces this sound and again it controls the sound generator. The microprocessor, you know, is basically used to communicate with KB, the keyboard and control panel. This is basic purpose of the microprocessor, to communicate with the keyboard and for the control panel. It sends and receives the MIDI messages now. We have not given you information about which microprocessor, but not more than 8 bit or 16 bit microprocessors must be required, right. Keyboard provides direct, what is the purpose of the keyboard here, because it is also component of your synthesizer. Keyboard provides direct control of synthesizer. The control panel, what does control panel do? Control panel controls those functions that are not directly concerned with the keyboard. For example, panel controls include the slider that controls the overall volume of a synthesizer. So, basically the purpose of the control panel is to control the volume of the sound, they control the amplitude of a sound, loudness of the sound, increase, decrease, keep at certain optimal level and so on. The MIDI message, the different type of messages are there. MIDI messages transmit informations between MIDI devices and determining what kinds of musical events can be passed from device to device. The different type of messages are there, just like in when you study the TCP/IP or let us say study the SDLC, that is data link layer protocol. The different type of messages are there. One is called the what we call control message, right, and the second might be the actual data informations and so on. So, here again the different type of message passed between are passed between musical instruments. So, one is what we are talking about is the channel message, and second is called system message. I will not go into detail, simply explain the difference between the two, right. So, basically what we are talking about, the different type of message passed between musical instrument, and these instruments are programmed to understand what comprises this message, what comprises the another type of message now, and what does channel message contain, what type of information it carries. Now, the channel message are those which apply to a specific channel. We talked about 16 channels are there, what each channel is going to do. Like in computer network also we are talking about what various type of channels are there, right. It is not a physical channel, but logical channels now. So, channel message are those which apply to a specific channel, and the channel number is included in the status byte for this message now. So, this if it is for a particular channel, then it includes that channel number, right. Whereas, the another type of message, what we will call them system message is basically not channel specific, it goes to the entire MIDI system. That is why no channel number is assigned to it, whereas in channel message it contains channel specific informations in the byte sequence. Now, we go to the MIDI file now. Now, what is the MIDI file, right? The MIDI file is because all the informations are stored into the file now. So, what MIDI file comprises of? This is my last topic. A MIDI file is a data file that contains musical informations. Specifically, a MIDI file stores MIDI data in the form of commands. So, all the musical file, all the MIDI file contains different type of commands which has to be interpreted differently by different musical instruments now. That musical instruments transmit between each other to control playing notes and adjusting an instrument sound. So, basically what we are talking about is a MIDI file is a series of commands given from one computer to the musical instrument, or from one musical instrument to the computer, or vice versa, right. Is a basically binary file. I know the what exactly we mean by the binary file. Is a binary data, it contains the binary data, and MIDI file is therefore a binary file. Since it is a binary file, you cannot use with a text editor. You have seen that if you write a program in Java, is basically it is if it is the bytecode you simply can't visualize, you can't able to interpret on your machine and so on, right. So, you basically can't view them through your editor and do anything with this binary file. The MIDI file format was devised to be able to store any kind of MIDI message along with the timestamp. So, and each command contains certain timestamp value, right. By timestamp, you understand what we are talking about. What is, for example, Unix has own file format, the Microsoft Windows has own file format. Now, for example, if we say the Unix file, it is a basically sequence of bytes. But when you talk of the Microsoft file, or let us say window file, is a sequence of records now. So, that is the difference. Same way, the MIDI file is own formats now, but there is a standard now that the file format will be understood by all musical instruments now. So, and each command is basically series of commands or or events for different musical instruments now, but each command contain certain timestamp value when the value, I mean when the command was generated. Just like for example, when in TCP IP protocol, when you send a packet, the timer is on, right. Same way, certain time, so that it can be played back by the another instrument easily. So, the timestamp is simply the time when the message was generated using the timestamps. The sequencers can play back all of the MIDI message only because of the time they know the sequence in which all the events has to be played down. If there is no time event, again it will not, it is not a simply text file. Each timing has to be totally synchronized, whereas audio file is concerned. The MIDI file is a generic standardized file designed to store musical performance and is used by many sequencers. So, basically called generic standardized file. The MIDI files are not specific to any particular computer platforms, right, or products. there are 3 different types of MIDI files are there. They are not specific to particular computer, that okay, for the 8086 machine there is MIDI file will be this one, for a Pentium machine MIDI file will be different. So, basically independent of any computer platforms it has been designed, and there are 3 types of MIDI files are there: type 0, type 1 and type 2. Type 0 files contains only one track, depending upon what track, how many tracks was used, that is where the difference lies. The type 0 files contain only one track, and entire MIDI messages are placed in one track, even if it represents many musical parts upon different MIDI channels. So, informations are for many channels, but everything is crammed into just only one track. This is what we call them type 0 files are there. What about type 1 file? Type 1 file separate each musical part upon its own track. Both type 0 and 1 store one musical performance. So, basically it is related to type. So, basically when you do the video recording or audio recording, you use different tracks. So, basically which track, how many tracks, what each track contains, based on this factor we differentiate between type 0 and type 1. And there is a type 2 files. Type 2 files are basically, which are extremely rare, are akin to a collections of type 0 files all crammed into one MIDI file. Type 2 is used to store a collection of songs or patterns and something like this. The MIDI files stores the MIDI messages, which are commands that tell a musical device to what to do in order to make a music. So, this is what we are talking about, what the MIDI files contain. Anyway, we will not going into detail. Anyway, this way I have finished the sound, which was a larger topic in the multimedia domain. We explained you the basics of the sound, we explained you the file size required for this one, we explained you how to do the conversion from audio to the digital. In this context, we introduced the PCM, that is the digitization techniques. We explained you various parts of this one, and finally we explained you that is the interface which has emerged, which is a standard between the musical instruments and the computer. And also at the end we explained you what does MIDI file contain, right, is series of commands or series of events for the musical instruments.